Okay, I'll get going here. Thanks for joining, everybody. Today's ANSYS webinar, we're going to be talking about PCB design flow using ANSYS, Siwave, and Zuken. The presenter will be Stephen Anchong Liu from Ozen Engineering. This is Chris Cowan, and I'm just giving a brief intro for a minute or two. So, my company is Ozen Engineering. We're a company that's focused on physics-based simulation to solve multidisciplinary engineering problems. We use CAE tools for finite element analysis and computational fluid dynamics. Ozen Engineering is an ANSYS channel partner and software distributor in California. So that means that we provide software sales for ANSYS products, training classes for ANSYS products, technical support for our ANSYS customers, and we also provide engineering consulting services. We operate in the fields of fluids using computational fluid dynamics, structures, mechanical and thermal using ANSYS mechanical, electronics, and multiphysics. Recently, ANSYS has added optics capabilities as well. So we're working in optics. You see virtual reality at the bottom. We have tools for online design collaboration in virtual reality. Also, we offer cloud services, hardware and software for solving your computational simulations on the cloud. Ozen Engineering is based out of Sunnyvale in the middle of the Silicon Valley in California. We also operate on the East Coast through partner companies Mallet Technologies and CADFEM in North Carolina, Maryland, and Michigan. So this week's webinar is PCB Design Flow. We'll be hosting a webinar every Wednesday for the next several months. You can see the list of topics here. I'd like to invite you to join. You can register through the ANSYS website under events or through the Ozen Engineering website, ozeninc.com/training. We'd like to be your partner, help you solve whatever engineering challenges that you have. Feel free to give us a call and we'll talk about how we can use simulation to attack the problem. You can contact us at info@ozeninc.com. You can call us or go to our website. So without further ado, I'll turn this over to Stephen.
Okay, thank you, Chris. Okay. Okay, my name is Stephen Liu. Again, I'm phoning from Ozen Engineering. Today's topic will be the PCB design flow with ANSYS Siwave and Zuken. Is everybody seeing the screen all right?
Yes, I can see the screen just fine, Stephen.
Great. So the main products we're looking for today is ANSYS Siwave and the Zuken CR8000. Before we get into the softwares, let's start with what are PCBs. So PCBs are a non-conductive board that holds our electronic components through circuit embossed over it. They can be built for a wide range of industrial, commercial, and domestic applications. Nowadays, we are emerged with the electronics devices. Inside each of these electronic devices, there are thousands of components put together that enable specific desired functions. Products from high-end to low-end, we have cell phones, computers as high-end products, all the way to the low-end products such as the garage gate remote. maybe even your toothbrush can be electric. So it's also safe to say that PCBs are the backbone of electrical devices. It can and it can also be customized to any specification to users' requirements. uh, in terms of different types of the PCBs, we have single-sided PCBs that's base material, with rigid laminated with a woven glass epoxy base material clad with copper on one side. We have double-sided PCB that can be assembly encompasses a base material with copper on its both sides and also a more comprehensive as multi-layered. Other specifications for the PCBs, if we're talking about from a board style standpoint, we have rigid flex, and hybrid types of PCBs. If we're looking from a parts perspective, we have active parts on the PCBs, such as diodes, transistors, integrated chips, also passive components such as capacitors, resistors, inductors, and we also have pads, traces, vias, etc. etc. In terms of package types, we can categorize PCBs into surface mount or through hose. Uh, there's also different material options for the PCBs, uh, substrate, conductor, adhesives, protective coating. So now let's take a look at a typical PCB design flow. So from step one, we started with a concept layout for the PCB. Then we start to design the PCB from an electrical engineering perspective and a mechanical engineering perspective. If we were to make a product, in this case, we're looking at a AC product, air conditioning product. So at the step two is where mechanical engineers and electrical engineers branch away to start working on their own portions of the project. For mechanical engineers, they will start to design the housing, packaging, or shell of the product. Electrical engineer stays on a path to build electrical functionality that are desired to the that are desired to have in this product. Uh, uh, Starting from step two, we enter step three, four, five, six, seven, where uh, where is we assess the cooling performance on this air conditioning PCB. As you can see from step three, we test the concept cooling strategy. Then we determine at step four there might be a heat sink needed. On step five, we optimize the heat sink by assessing what's the best location to put the heat sink at. And then on step six, we import the EDA PCB design. Uh, if you think one more step close, we can step one and two are really the design stages, and step three, four, five, six are really the simulation stage. So with the tools that I'm introducing today, the two tools that I'm introducing today, we can really um, complete this uh, PCB design flow by just using two tools without actually prototyping. So as we said before, for design, we use Zuken. For simulation, we use ANSYS. So let's first take a look at on ANSYS side because we are an ANSYS distributor. Um, this is the tool. This is the ANSYS tool. This is our ANSYS solution for the PCB simulation. It's called Siwave. Uh, it we, on this slide we're looking at the general desktop of Siwave. On the left side we have uh, Nets Nets library. Right now we're looking at single-ended nets. The one good thing about this tool is that if it can automatically recognize the nets, single-ended, double-ended, differential, from the ECAD that you imported. And then it can also recognize the components on your from your ECAD file. And on the top, we're looking at the manual, and there is a it's a now it's a with the new 19 release, it's a ribbon style. I'll show you later. So what is SI Wave? It's a electromagnetic based software solution for power ground plane and signal integrity analysis. It employs a powerful full wave analysis engine to generate both frequency domain and time domain results using the highly optimized internal field solver. SI-Wave simulates complete board package design with full wave accuracy. Simulation results can be reported graphically using advanced 2D and 3D plotting methods. Um, so it it's really it's a platform. It's a platform with numerous solvers built in that you can choose from. It has for field solvers we have HFSS, which is another flagship ANSYS flagship product. And also Q3D extractor for parasitic and electrostatic analysis. Also CPA and PSI, which is SL Wave unique solver. It also it can also coupled with thermal solvers, which is IcePack, another ANSYS product that specifically deals with electronic coolings. It also includes circuit solvers, uh, Nexium and Synopsys or HSpice. Based with all these solver capabilities, the type of analysis we can perform in SI Wave, including signal integrity, power integrity, DC-IR drop analysis, EMI, EMC, decoupling capacitor optimization, and PSpice, HSpice, and spectral circuit analysis. And so we're t- so the, a lot of the focuses in the PCB industries is to assess the signal and power integrity performance. So what is signal and power integrity? It they determine basically it determines if a signal transmit from point A as a logic level 1 will be received correctly at point B as a logic level 1. With that being said, if a poor signal integrity or power integrity design creates electronic noise that can become EMI, but proper placement of decoupling capacitors and routing of signal removes this noise. So for specifically for power integrity and signal integrity, we have the SI Wave has these listing core solvers to tackle the problem. For power integrity, we can utilize 3D DCR solver with adaptive mesh refinement. And speaking of mesh refinement, it's another I would say flagship technology within the ANSYS electronics suite with the EPU products. By mesh refinement means that the mesh. So first of all, in the electronics products, engineers and users don't need to do the mesh manually. It always creates mesh uh, on its own, and you can specify the fineness of the mesh without actually uh, do the mesh, and you can specify a number of passes uh, for the mesh so that with each adaptive pass, uh, the results would refine itself based on the mesh refinement. Basically, the mesh for let's say we set for 3 passes for mesh refinement. That means software will mesh the entire package or PCB 3 times, with each time more denser on the significant parts and components where we care about, so that the results will be more accurate. So if we continue on this slide, we have other solvers for power integrity, such as 2.5D AC SYZ solver that will gives you SYZ parameter. On signal integrity, we can do impedance and crosstalk scans for PCB and packages. We could also do the same for SYZ using SYZ solver for a fast and high capacity hypersolver. And we also have signal net analyzer that does impedance and flight time solves. SI Wizard is specially created for the signal integrities, so that we can provide you with eye diagrams to determine whether we have a good or bad signal integrity. On the top, I just showed you the ribbon menu style we recently have. If you take a look at we are on the simulation tab right now. Look at how many different modules and functionalities SIWave have. So SIWave as a product, it comes with 3 different packages. Starting from the most left, it's SIWave DC with the DC capabilities as well as the A-links for EDA. It's an ECAD translation, which we'll talk about a little bit more later. The DC analysis mostly focus on low voltage, high current PCBs and IC packages, enabling assessment of critical end-to-end voltage margins to ensure reliable power delivery. It would also allow you to perform pre and post layout what-if analyses for DC voltage drop, DC currents, and DC power loss. And then we step 1 level up, we have a SIWave PI package. It includes everything that the DC package has, and it also adds AC analysis to accurately model power delivery networks and noise propagation on PCBs. This package is ideal for analyzing power integrity distribution challenges and automatically optimizing decoupling capacitor selection and placement. And then with one step above, we have the comprehensive SIWave package that does almost everything we just mentioned before, and also has SI circuit that includes IBUS and IBUS AMI component library. It also, and one key thing that this package have is the robust and ANSYS Nexium time domain circuit simulation engine, so that it would enables a fast impedance and crosstalk scanning with visual and a color coded feedback in HTML reports. So on that's the different packages we provided with SIWave. If you look at the top of the this slide, we also have you can also tell that the SIWave core solvers can couple with other physics within ANSYS suites. On the left side, it can couple with Workbench, which is our mechanical and fluids solutions. On the right side, we have IcePack, which is something we mentioned before. That's a electronic cooling product. Well, once you have, especially with the IcePack, it's you can invoke, you can do a temperature, you can do a Joule heating and temperature simulation that so that you can bring the Joule heating data and the temperature mapping into IcePack to help you do a electronics cooling solution. So by doing so, the closed loop calculation, this SIWave coupling with IcePack can gives you successful insight into the thermal behavior of key PCB sections. We also mentioned a little bit about the ECAD translation before. If you are a user for this software, you definitely would care about what type of ECAD database it can bring. Good thing is that SIWave recognize most of the nowadays vendors file format. From Cadence, it can recognize Allegro, APD, SIP Digital Virtuoso for monograph and most of the monographics, as well as the ODP++, of course Zuken as well. So with all these um, translations, SIWave provides seamless and integrated design flow that allows you to import layout geometry from major ECAD providers, easily import design geometry from commercial layout packages uh, such as Designer, SI, you know, Posonics. This slide is a table format of the previous two slides. It basically summarizes the capabilities in different SI wave packaging. So one thing newly added to the capabilities is this Iron Python, and also the Synopsys and Synopsys H-Spice, Cadence P-Spice are also newly added as well. Everything else we have mentioned a little bit before. So this page is a highlight of the last version of SI Wave update list. Uh, in However, in this year, by the end of January, all customers should be able to access the new ANSYS 2019 R1 version release, and we'll have a follow-up uh, presentation on that. On this page, it's some simple results that I generated from Siwave. The first one on the left side, on the left upper corner is the resonance mode. It can On the right upper corner, it's DCI drop of current density on the board. On the lower left, it's PCIe card power distribution, and on the lower right, it's PCIe card power loss mapping. Now let's take a quick look at SI Wave. So right now there's already a PCB open. I can do this one more time. I will start a new project. So this is the general look of the SI Wave. We have a ribbon style, which is very user friendly. Uh, Here it enables you to import different kinds of ECADs, EDAs, and other imports. We have home, view, tools, advanced, export. By the way, the SIWave can export the design or the project into other ANSYS products, as I mentioned before. You can export it or design into HFSS 3D, which is uh, sort of a slightly variation of the standard HFSS. We can also export it to Q3D, export it to Maxwell 3D, do a uh, power simulation, and also IcePack for electronics cooling. And as we saw before, there's different simulation that you can perform under here. And also we can take a look at the different performance results on the project. So now let's open a board that I just created, that I generated from Zuken. So we do a import and ANF as ANSYS neutral file. This is the neutral file that's exported from Zuken Design Force, which is another software we're going to talk about in a minute. So after the import, it will ask you for configuration, just to for you to check if all the net names are correct as you designed. Once you have it imported, there is a Siwave workflow wizard that allows you to gives you the option to do an automatic verification for stack up, pass stacks, or circuit element parameter. The whole purpose of this wizard is it's optional for the users, but it's definitely a good tool to help the users to verify their designs or import, see if anything is missing, everything is all right, if the via or stack up is correct. So we'll skip this step, and now we have this board imported. It looks a little strange because the Z direction is stretched. With with this open, we can do a lot of analysis on it. I will skip you with the steps, just directly show you the results. So here, as you can see, I did some simple analyses on the DCIR simulation, where it can uh, now this map is showing you current density on every layer, on basically everywhere on the PCB. You can, of course, you can unselect them, just looking at one layer or all of them. And there's also via current to allows you to see the current going through the vias. That also allows you to look at the voltage mapping on the board and also power distribution on the PCB as well. And I believe I haven't done this yet, but this is exactly the power mapping that I'm talking about, so that you can send it to ISPAC for electronics cooling. There's also impedance scan to scan different all of the nets on the PCBs to see if there's any violations. The rules are set by yourself. You can set the warning tolerance at 10% or violation tolerance at 20%. You can also change it to 20%, 30%. It's really how you want to have your rules to set it up. And of course, also crosstalk scan. Something doesn't pops up. You can also do a resonant mode simulation. That gives you different frequencies. It allows you to plot voltage difference between planes. Say on the conductive layer 1 and 2, if we want to do a phase animation, you can tell the difference of different, you can tell the voltage difference between the planes, basically. So there's a lot more to explore. If you are interested, contact us for more information. So now I'd like to talk a little bit about Zuken. So as Chris introduced before, we are ANSYS distributors, but also as channel partner, as a consulting company, we're partnering with Zuken America to sell this Zuken product as well. So the key features and the benefits, as listed here, the number one is Zuken and ANSYS have a strong partnership and roadmap for simulation. And it also, the Zuken define the store simulation parameters and the model information in Design Force, which is the product of that we do this design at. Uh, the whole suite of this product is called CR8000, and there's a couple different uh, products in it, and then the main product is called Design Force. So with Design Force, uh, as you can see, it can be coupled with ANSYS. It can be directly coupled with ANSYS Simpler to allows you to do a system level electromechanical logic simulation. And as you can see, it can export into ANS or EDB or step files so that it can be passed to uh, different ANSYS solutions such as HFSS, IcePack, mechanical, etc. Um, so most of these connections are bidirectional, uh, so that so that the users can reduce manual rework. Um, So Design Force, as we are talking about, is a native 3D architecture enables direct integration of CAE tools. Uh, Zuken is now collaborating with best-in-class CAE companies for direct integration. Some of the target benefits they're looking at is allow engineers to prototype or conduct pathfinding studies in the same environment for production design, eliminate wasted and error-prone handoffs in design process, motivate all members of the design process to co-simulation across design process to improve design quality and save cost of design respins. So there's collaboration. This is the collaboration summary with best-in-class CAE tools that Zuken has been partnered with. So without further ado, let me quickly show you a YouTube video on Design Force. So this is a capability within Design Force where you can switch between 2D and 3D view, and you can do the trace mapping either in 2D or 3D view. So this is a 3D technology editor screen so that you can look at the layers from a different perspective. And it's also this design tool is also a multi-level design tool, so where you can map the traces across the layers. So this is about it. There's more to show definitely, but for some reason my Zuken license isn't working today. Um, but yeah, if any of you guys are interested in more information, feel free to reach me. And this is about it for today's webinar. Thanks everybody for your attention. We're looking forward to see you in the future. And have a nice day.